Study about least common multiples of an algebraic expression. Let's recall how to find the least common multiple. Okay, in the abbreviation we call it as LCM. How to find the LCM for numbers? For an example, at which instance we have to use LCM? That's really important. So in fractions, we know that 1 over 5 plus 2 upon 5. When you have two fractions like this, in the addition or subtraction between fractions, you should have the denominator as the same value. It is must. If your denominators are not same, we cannot add the fractions or subtract the fractions. Since the denominators are same, we can write the same denominator to our answer and add the numerator values. 1 plus 2, it would be 3. We cannot do the operation as sum in the denominator. If the denominators are same only, we can write the same denominator to our answer and do the addition operation between the numerators. We know that at that time we are using LCM. If the denominators are not same, likewise 1 upon 7 and 2 upon 3 in this case, look at this. The denominators are not same now, so we cannot add them directly. 3, 7 plus 3, it's 10. We cannot do these kind of silly things here. So you have some kind of idea, the better idea about sum of fractions. So that's what here also we are applying. If the denominators of fractions are different, we have to find the LCM to get the common denominator. At that place, we are using the least common multiple. We will find some values for least common multiple as example. Yeah, I'll use number 4 and 7. I'm going to find the LCM for 4 and 6, these two numbers. So you should bring these two numbers to here to do the division. Okay, it's called as L kind of division or long division. You should do the long division by using prime numbers. What are our prime numbers? 2, 3, 5, 7, 11, 13. The numbers which are only having two factors, those are called as prime numbers. So you should use the prime numbers to do the division while finding the LCM. There are so much in LCM. At where you have to use the LCM? When the denominators are not same while adding or subtracting the fraction. So to find LCM, you should have the prime numbers for the long division. So first I can divide both of them by 2. 4 divided by 2 it's 2. 6 divided by 2 it is 3. Again also you have to check whether if there is any 2 multiple still exist or not. There is a 2 multiple inside furthermore. So I can divide this again by number 2. 2 divided by 2 it's 1. 3 cannot be divisible by 2 because 2 is not a multiple of 3. So this 3 remains same. Thereafter check whether if there is any 2 multiples still exist or not. There is no more 2 multiples. Now let's move to our next prime number, that is 3. So after that we have to move to number 3. 1 is already found. 3 divided by 3 it is 1. So LCM for these two numbers 4 and 6, it would be, to find LCM you have to find the product of prime factors. These are factors. Since these are prime numbers, we can name them as prime factors. You should have the product of prime factors to find the LCM. So 2 times 3. It would be 12. That would be the LCM for these two numbers, 4 and 6. Not only here, we will try another example with numbers 3, 10, and 12. These are the numbers I'm having. I'm going to find the LCM for these three numbers. Here also same thing. You have to do the long division for them. 3, 10 and 12. Initially I can use the first prime number 2 here. 3 cannot be divisible by 2. 3 still remains same as it is. 5 divided by 10. Sorry. 10 divided by 2 it is 5. 12 divided by 2 is 6. Again also I have to check whether if there is any 2 multiple still exist or not. There is a 2 multiple. At least if there is a 2 multiple, you should use number 2. 3 and 5 are not divisible by 2. 6 divided by 2, it would be 3. Again, there is no more 2 multiples. Now let's move to our next prime number, that is 3. 3 divided by 3 is 3. 5 cannot be divisible by 3. That remains same. 3 divided by 3 is 1. Okay. Check whether if there is any 3 multiple still exist or not. There is no any more 3 multiples. So you have to move to your next prime number, that is 5. 1 remains same. 5 divided by 5 it's 1. 1 divided by 5. So no need to divide that further. Don't divide 1 by 5 and write 0.2 here. Okay. If you received 1, 1 is the desired output we need. So if you received 1, 1, 1 or 1, 1 like this, that's all for our division. Then let's write our answer. LCM for these three numbers. Product of all these prime factors. So 2 times 2 times 3 times 5. 2 2s are 4, 4 3s are 12, 12 5s are 60. So 60 is the LCM for second set of numbers. So here there are two questions. For the first question, 6 and 8, I will simplify. 6 and 8, first of all, we can divide this by 2, so 3 and 4. Again also we can divide this by 2, 3, 2. Again also you should divide this by 2. Sometimes you will have some kind of doubts. Okay? Why can't we divide that directly by 4 or 8? Because 4 and 8, those are not prime numbers, so we cannot use anti-prime numbers in these kind of LCM division. You must use the prime numbers. So that's why even though it is having most steps, you should use 2 as your number. The one and only prime number in even numbers, it is 2. Then let's move to number 3. One time, one time. So LCM for these 2 2s are 4, 4 2s are 8, 8 2s are 24. And next set of numbers 4, 10 and 14. For that one, initially 2. 2, 5, 7. Again also 2. 1, 5, 7. Again there is no any 3 multiples. Directly let's move to number 5. 1, 1, 7. Next number 7. So it would be 1, 1, 1. So LCM for these three numbers, it should be 2 times 2, 4. 4 times 5, it is 20. 20 times 7, it should be 140. 140. Here you have to use number 2 twice. We are having number 4 now. So 257. Again also you should use number 2. Thereafter you can move to number 5 and 7. Finally the answer would be 140.